Hello aspirants, welcome back to SKD's node. So today we are going to discuss about some important MCQs on basics of electrical engineering, okay, which are very much important for your competitive exams. So without any further delay, let's get started. So we have question number 1 here. If 1 amps of current flows in a circuit, the number of electrons flowing through this circuit is how much? So number of electrons which are flowing through the circuit is how much they are asking. So we know that charge on one electron is nothing but how much? So charge on electron is 1.6 into 10 raised to minus 19. So at the same time they are asking for 1 ampere. What is the charge transfer of 1 coulomb? Is nothing but 1 divided by 1.6 into 10 raised to minus 19, which will be equals to 0.625 into 10 raised to 19. Okay, so option A is the right answer. In some cases they may give option called 6.25 into 10 raised to 18. So this is also correct. So they are just shifting a decimal to the decimal point. Okay, so next we have question called the resistivity of the conductor depends upon what? So as we discussed, the resistivity of the conductor is always depending upon the type of material, okay, not the length, not the area. Resistance is depending upon the length of the conductor and area of the conductor. Okay, so you can eliminate these two by checking directly. So these are with respect to resistance. Type of material comes means it is resistivity. Okay, so that is the answer. So next we have question called the resistance of a conductor of diameter d and length L is R ohms. If the diameter of the conductor is halved and its length is doubled, then the resistance will be what? They are asking. Once again I'll read it. Okay, the resistance of a conductor of a diameter d and length L is R ohms. If the diameter of the conductor is halved, that means half, and its length is doubled, then what will be the new resistance value they are asking. Okay, so while solving any MCQs and whenever a lecturer or faculty is telling you some problems, okay, you just pause the video and try to solve by yourself first. Later you unpause the video and check for verification. Okay, so let's solve this. We know that R equals to rho L by A. Okay, instead of A they are saying D. Okay, so this is a conductor, this is area, correct, which is equals to diameter, then this will be the length. Okay, what they are saying, length is doubled whereas area or diameter is halved. That means our R new will be, first let me write here. Okay, length is doubled, correct, 2L, then area is halved or diameter is halved. So this 2 goes to the numerator, then it will become 4 times rho L by A. So your R new will be 4 times the actual resistance. So answer is C, that is 4 times the actual resistance. So let's see next question. So here they have given how many coulombs of charge flowing through a circuit carrying a current of 10 amps in 1 minute. So once again pause the video and try to solve it by yourself. Okay, so let me solve this. So we know that Q is equals to I into T, where I is current in amperes, T is time in seconds. So here they have given in minutes, so we need to convert that into seconds. So 1 minute is equals to 60 seconds, correct. So then Q equals to, what is I? They have given 10 amperes, correct. Here they have given 10 amperes into 60 seconds, it will be 600 coulombs. Okay, So what will be the answer? Option C will be the answer, that is 600 coulombs. So next we have a capacitor carries a charge, that is Q, of 0.1 coulombs and at V, that is voltage at 5 volts, then what is the value of capacitance they are asking. They have given options as 0.02 farad, 0.5 farad, 0.05 farad, 0.2 farad. Okay, so let's see what is the answer. So we know that Q is equals to C into V. So what they are asking? They are asking C. So then it will be Q upon V, then 0.1 divided by 5 will be 0.02 farad. So this is the A is the option. So next we have, to obtain higher value of capacitance, the permittivity of dielectric medium should be what? It should be low, or it should be 0, or it should be high, or it should be unity. First of all, how this permittivity and dielectric medium is related? First you need to quote the formula. So epsilon A divided by D. So here permittivity is nothing but this epsilon. What they are asking, what is high, if you want to get higher value of capacitance, what is permittivity? So if here we can say capacitance is directly proportional to permittivity. So as permittivity increases, capacitance value also increases. So here it should be high. So option C is the answer. So next we have, if 4 capacitance of each 40 microfarads are connected in parallel, the equivalent capacitance of the system will be how much? So they are given options as 160 microfarad, 10 microfarad, 40 microfarad and 5 microfarad. So we know that when 4 capacitors are connected in parallel, okay, what happens? They are gets added. So I'll tell you one thing, connection of passive elements. Okay, so all our values are 40 microfarad each, then you need to add all the capacitors. So 40 times 4, it will be 160 microfarad. Instead of adding, I am just taking one capacitor and multiplying with 4. So this will be 160 microfarad. Here next see the question. Okay, I have another question also. So if 5 capacitors are connected in, each 5 microfarads are connected in series. So here they are saying series, the equivalent capacitance of the system will be how much? 5 microfarad, 25 microfarad, 10 microfarad or 1 microfarad. So let's solve this. Okay, if you want to solve this, try to solve it by pausing the video. Okay, so here 4 or 5 capacitors, 1, 2, 3, 4 and 5, all are connected in series whose values is 5 microfarad. Okay, so here in the case of capacitance, when they are connected in series, its equivalent will be 1 divided by C equivalent will be 1 upon C1 plus 1 divided by C2 plus 1 divided by C3 so on plus 1 divided by C5. Then it will be 1 divided by 5 plus 1 divided by 5 plus 1 divided by 5 plus 1 divided by 5 so on. So you will get as, so 1 divided by 5, what is the value? It's 0.2. So 0.2 times 5, it will be 1 microfarad. So option D is the answer. But in the case of resistance, when resistance, let me tell you another concept here. Resistance in series. Okay, so when resistances are connected in series, R equivalent will be sum of all the resistances. R equivalent will be R1 plus R2 plus R3. Similarly, okay, so in case of inductance also, okay, if all the inductance are connected in series, their equivalent value will be sum of all the respective inductance value. Okay, then L equivalent will be L1 plus L2 plus L3. Okay, but this is not in the case of capacitance. When capacitance are connected in series, okay, it will be C equivalent will be 1 divided by C1 plus 1 divided by C2 plus 1 divided by C3. Okay, remember this. So next we have, okay, so let's see next one. So we have ninth question here. The voltage induced in the inductor is represented as dash. So they are given options as product of its inductance and current through it, so ratio of its inductance to current through it, so ratio of current through it to its inductance, or product of its inductance and rate of change of current through it, they are asking. Okay, so here we know that induced voltage is nothing but L into di by dt. Okay, so what is there? Rate of change of current and product of inductance. So this will be option D. The induced voltage in an inductor is represented as product of its inductance and rate of change of current through it. Okay, so next we have permittivity. So we have question called permittivity of dielectric medium is defined as what? So first we need to see, we have relative permittivity. Okay, permittivity is related with capacitance, whereas permeability is related with inductance. When permittivity, when dielectric comes, it talks about capacitance. Okay, remember this. So you will be having capacitance, here it will be a dielectric medium. This dielectric medium can be calculated with the help of, when relative permeability is nothing but actual it is the ratio of actual permittivity to the absolute permittivity. So they are asking about permittivity, so it will be epsilon times epsilon or epsilon naught. So this will be the solution. So this is the answer. So next we have, which of the following is or are an active element? So we know that when there is a family in electrical engineering as well as in your life, father and mother are important, they are active, without them we are nothing. Likewise in electrical engineering, so without voltage and current we are electrical engineering is nothing. So voltage and current are what? Active elements. So here answer will be what? Both A and B. Okay, both A and B will be the answer. Then we have, which of the following are the passive elements? So when it compares with your family, passive elements are nothing but kids in a family. Okay, likewise in electrical engineering, all the passive elements, that is resistance, inductance, capacitance, these are called as what? Passive elements. See here, resistance and bulb, and both they are given. So bulb, what it contains? It contains resistive element, that is it will be both. So next we have, if the power dissipation in ideal inductor is what? So the power dissipation in ideal inductor is what they are asking. So recently in AC circuits, in the previous session we have discussed that power dissipated in an ideal inductor or capacitance circuit will be 0. So answer is 0. So here now next question will say, so internal resistance of an ideal voltage source is what? So you will be having a voltage source, okay, and its internal resistance will be almost 0. Okay, why? Because they should conduct or they should deliver some source, and it will be having some built-in source which will be supplied to the circuit, or when they are ideal they will be having some source power in them, so there will be resistance 0. So internal resistance of ideal current source is in what? Infinite. Why? Because in order to see, ideal current source will be having some high value of current, so in order to have this, it will be having infinite value of internal resistance. Okay. So next we have, which of the following has no unit? So permeability, we know that it is related with inductance, Henry per meter. At the same time, permittivity is with respect to what? Capacitance, that is farad per meter. So here moment of magnet also will be having some unit. So here magnetic susceptibility, that is magnetic susceptibility will be what? It will be I upon m. So it won't be having any unit. Okay. So option C is the answer. So next we have, RMS value is defined based upon which of the following? Heating effect, charge transfer, current or voltage. So in previous session we also discussed about root mean square value in our part 3.2 session, correct? So RMS value is regarding with the heating effect. So whenever a voltage is subjected or a power is there in an circuit, heat transfer is same in the AC when the same amount of heat is transferred in DC at the same time is nothing but what? RMS value. Okay. Heat dissipated in an circuit when they are connected in AC is same as when DC at the given time in the given circuit. It says about heating effect. So next we have, which of the following defined as the average value? So average value is nothing but the voltage required for the charge transfer when connected in AC for the given circuit for a given time is same as DC when given circuit in a given time. So it talks about charge transformer. Okay, transfer. So next we have, for symmetrical wave from symmetrical waveform, average value of one full cycle is what? They are asking. So for symmetrical wave, so you will be having 0 as the value for one cycle because they will get cancelled. So positive half cycle and negative half cycle will be get cancelled when they are averaged. Okay, so you will be getting 0 as the answer. So next we have, form factor is equal to the peak factor in the case of square wave. Okay, so it will be equivalent to 1, where form factor in the case of sine wave it will be 1.1 and peak factor it will be, you know the what is form factor, correct? Ratio of RMS value to the average value. So whereas the peak factor is nothing but maximum value to the RMS value. So next we have next question. So if pure inductor is connected across a AC source, the average power taken by an inductor will be what? 50 watt or 100 watt, 0 watt. See here you can go with the elimination technique. So they have not given any values, so 100 watt will be eliminated, so few watt will be eliminated. So you will left with these things. Okay, whenever a pure inductor is connected across AC supply, it will offer 0 power. Okay, power dissipated will be 0. So the 0 watt is the answer, not maximum power also. So next we have, average power taken by the pure capacitor is what? Same as I said, whenever pure inductor and pure capacitance are subjected to AC supply, they will be having a 0 power. Okay, ideal in pure capacitor. Okay, there won't be any resistor or inductance, or there won't be any resistor. Then pure capacitor is connected with AC, then power taken will be, or average power will be, or true power will be 0. So next we have, in a series RL circuit, voltage across resistor and inductors are 3 volts and 4 volts respectively. So then what is applied voltage? So he is asking for V. So we know that R and L is connected in series. So here VR they are saying 3 volts and VL it is 4 volts. So total voltage or applied voltage they are asking. So it will be under root of VR square plus VL square is nothing but under root of 3 square plus 4 square. It will be how much? 3 square is 9 and 4 square is 16. So it will be 25 and it will be 5 volts. Correct. So next we have in an RC series circuit, a total voltage is 10 volts and voltage across resistor is 6 volts. Then what is the voltage across capacitor? See, here I want to warn you. So while solving these kind of questions, when they are given back to back, don't do it in hurry burry. They are asking here total voltage. Don't take it as a resistance voltage and inductance voltage when they are given in RC series circuit. Read the question carefully. Okay, they are given total voltage V as 10 volts and VR as 6 volts. They are asking to find about what is the voltage across the capacitor when RC circuit is given. So RC, they are given what? 10 volts. Okay, they are given this 16 volts. Here Vc we need to find. So we know that Vt equals to under root of Vr square plus Vc square. Then you will get 10 equals to under root of 6 square plus. So then we need to find Vc square. You will get Vc as how much? 8 volts. Okay, the square will come this way and 10 square it will become 100 and 6 square will be 36. 100 minus 36 you will get 64 and under root of 64 it will be 8 volts. So then we have next question. In a series RLC circuit, voltage across resistor, inductor and capacitors are 5 volts, 2 volts and 2 volts respectively. Find the total voltage. So for that we have Vt equals to under root of Vr square plus Vl minus Vc whole square. Then they have given Vr as 5 volts plus Vl as 2 volts and Vc as 2 volts. It will become 0. Then we will left with 5 square. So it will be how much? 25. Under root 25 it will be 5. So answer will be 5 volts. So these are also some important MCQs which are related with basic electrical circuit. In previous session all part 3, part 1, part 2, part 3. So videos based on those concepts I have created some multiple choice question. I will be coming up with another part 2 multiple choice questions regarding with magnetic circuits and AC polyphase and single phase circuits. Okay, and in next session I will be taking electrical machines, which is very much important and having so much weightage. Okay, we will discuss about that in next class. After that I will upload part 2 MCQ video. So thanks for watching the video. Once again thank you. See you in the next session.